let's see, I guess the question here is, what relevance or what power does that have on the question whether a precise version of quantum field theory, an ontological version, or let me say an ontologically precise version of quantum field theory, should naturally or would be better off to use a particle picture or a field picture. And I think this question is very much open and not pre-decided by anything anybody has said, David Wallace, David Albert, or James. So these kind of fuzzy arguments like what people at CERN talk about, that just contributes, that is just intended to contribute to conveying that it's not clear-cut from the way one usually thinks about quantum field theory, what should be regarded as fundamental. Let me add another one of these fuzzy arguments to that, namely, quantum mechanics should be included in quantum field theory, right? We think of quantum field theory as having a wider range of applicability. It should be the better theory of which quantum mechanics is a special case. So if we have the view that in a certain regime that could be characterized as maybe kind of non-relativistic regime, in a certain everyday regime that the particle picture is good, then that should also come out of the whichever picture we have in the quantum field theory. Good. Let me move on to the next item here, namely, which is still about the particle position representation and whether that can be used or not in a formulation of quantum field theory. There's the question whether perhaps the particle position representation is imprecisely defined. So Wallace and Timpson have this formulation, it's imprecisely defined. I'm not completely sure what is meant by this, but I would guess they mean the following. Let's see, take away this. When we consider a certain region of space, let's say we have actually it doesn't make any difference. It could be a region of configuration space. And we may have an n-particle state, even in quantum field theory. Now, let's say this is the probability content of a certain region in configuration space. So we could ask the question, is the configuration in this region of configuration space, that's an associated probability. Now this is of the following form. Okay, this formula is kind of completely general, that's always true in quantum physics. But in ordinary quantum mechanics, non-relativistic theory, this P of delta is a projection operator. Actually, the position representation is just multiplication by the function that is 1 on the set delta and 0 outside. It's a certain projection operator. Now, in quantum field theory, in general, it's no longer a projection operator. It's still a positive operator, and it's still the case that these operators, when you consider a partition, you have several sets delta that add up to the whole space, then these operators add up to the identity operator, but it's not true that they're projections. I think this is what is behind, or this is one way of saying mathematically what is behind the claim that in quantum field theory positions are imprecisely defined. There is, for example, no position operator anymore. no self-adjoint position operator, because a self-adjoint position operator would correspond to projection operators for particular intervals of position or particular regions. But in this case, there are no projection operators, it's just positive operators. But the problem actually poses no difficulty for having a position representation, because it disappears in the following way. It can actually one can actually introduce a wave function psi, such that this quantity is exactly psi squared integrated over delta, and the only thing that one needs to do here is to consider two different spaces, a big Hilbert space that contains a smaller Hilbert space as a subspace, where this is the space of physical states. So the idea here would be that not all wave functions are possible physical states. This arises in several contexts. For example, in the Dirac equation, there are wave functions that have negative energy, and one usually says, no, negative energy, that's not possible. The physical states have exclusively positive energy contributions. So that's a situation where the space of physical states is a subspace of a bigger Hilbert space that contains wave functions, all sorts of wave functions, also those that are unphysical. Similar situations come up with photons. Now, this big Hilbert space that contains just functions, and if we take psi to be an element of this big Hilbert space, then actually we get back the usual formula for this probability, and then these operators P of delta become projections on this bigger Hilbert space. So the upshot of this entire story is this problem of imprecisely defined positions, which I guess means there are no position operators, can be resolved in a very easy and straightforward mathematical way. So that's why I think that this problem is overstated. Good. Next page. Primitive ontology. So that's what I want to talk about next. So here this could also be regarded as something like a new ontology for many worlds. So this is in a paper written by Valia and Nino and Shelley and myself last year, and it's forthcoming in the British Journal for Philosophy of Science. And the contents of this paper is essentially about a new ontology for many worlds. So this kind of nicely leads to the idea of comparing the two. Okay, now this approach is based on the concept of primitive ontology. Now let me formulate what primitive ontology means here now for the purpose of my talk. Primitive ontology is the part of the ontology that represents matter by means of variables describing the distribution of matter in three-dimensional space. So in order for some variables in the theory to qualify for being the primitive ontology, I want them to live in three-dimensional space as opposed to three n-dimensional space, and to have the meaning of describing the distribution of matter as opposed to describing probability distribution or describing, I don't know, something that is not matter, whatever. Good, here's some examples. Example number one, Bohmian mechanics. So in Bohmian mechanics, we have essentially two variables, the particle configuration and the wave function. So maybe I should write this in a somewhat different way to make it unambiguous what I mean by that, I should write it as Q1 dot 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 Qn stop. So these variables, that's the primitive ontology, and this variable, that's the non-primitive ontology.